I'm going to talk to you all a bit now about lighting. You're all here today because you've obviously in some way control of the buildings or properties that have lighting. But really nothing too technical, but also to understand how important the lighting is in that property that you look after. Lighting we'd like to think, or engineers think, is just an unnecessary consumer of energy. And unfortunately that's not the case. And I'm probably biased because part of my role is to sell lighting, so there's a bit of a sales pitch there as well. But lighting is a very important factor on how we perceive the world. It's one of the key ways we understand the world, and there's more and more evidence that that the lighting that we're subject to affects how we feel, how we perform, and how we interact with other people. Lighting is a very important factor to the quality of the working environment. And obviously sometimes that's essential, like if there's no lights, obviously you need some light. But what we fail to recognise, I think, in many situations is that better lighting will provide us with better outcomes. And why I mention that now is the big risk here, I think, when we're talking about saving energy, is that we're actually also going to save light. I mean, it's very easy to save energy, you can just turn the lights off. But that won't give us the necessary, or will give us the performance that we're looking for from our environment. If we look at how lighting affects us, and some of you will know things about lighting, some of you won't, so this is fairly general, and hopefully some of you find it a little bit interesting. But we're going to talk about how lighting affects us just briefly. And one of the things that you'll see recently is we talk about this thing called human-centric lighting. Now this is a sort of come to be popular recently, and particularly around LED lighting, this idea of human-centric lighting. Well, it's a funny name because hopefully lighting always has been human-centric. We didn't put lights anywhere that weren't for people, so lighting was always human-centric. And probably because of that, the global lighting network, if you like, have given it a new name, but it's a very strange name called integrative not lighting, which is a weird thing. So we'll call it human-centric lighting as a new thing. But what I've got here is just a simple diagram. And this just shows one of the things that affects this is with light is colour temperature. Lighting has been affecting us as people since the day we were born, and has been affecting our ancestors forever. And before, we only recently really invented, when we talk about artificial lighting, it was only recently invented in the last few hundred years. I mean, so lighting has been the basis of our circadian rhythm and of what we do every day. And lighting changes throughout the day. So this little simple, wrong button. This simple diagram here shows what happens to us. And you may know this, you may not. But when you get up in the morning, the sun rises, the lighting's very warm. As we go through the day, the sun rises higher in the sky. The lighting, the colour of the lighting changes. We say the colour temperature changes, the lighting gets much cooler. And then at the end of the day, the lighting warms up again as the sun goes down, and we go back to sleep. Now, you say, well, that's very cute, but why is that important? Well, this is part of our natural rhythm as people. And we all know, I mean, we may not have thought about this or even really understand this, but I think everyone understands that sitting by the fire with candlelight is very relaxing. Automatically, why is that? Well, it's a very warm colour temperature. Likewise, in the middle of the day, if you're out on the beach with a blazing down blue sky, blazing sun, you don't really feel very relaxed. It's you're quite excited about it. With LED lighting, new lighting, we can do lots more things than we could do before. We can start changing things around. And we'll just talk about that briefly, because when you start talking to anyone about changing lighting, they may bring up this topic. I've got another picture of that here, and I'm going to talk about lighting design in a minute, but I just thought I'd talk about this a little bit more. The first thing there we've talked about in the way that the lighting changes throughout the day is colour temperature. And I've already said that the warm colour temperature makes us relax, and lighting designers have been using this for a long time. Some of you probably didn't even know. A classic case of using colour temperature is somewhere like if you've been to McDonald's. McDonald's around the world actually light their restaurants to a very cool colour temperature. And that's why people go into McDonald's, they grab their food, they sit there, they eat it as fast as they can, they get up and leave. They didn't know it, but they've been conditioned. As a contrast to that, in New Zealand, Wendy's restaurants actually light their restaurants to a very warm colour temperature. And when you go in there, people sit there, they relax, they take a lot longer to eat their Wendy's than they do their McDonald's. It's just a thing they do. One of the big places that lighting colour temperature variation has been used has been in airports, and it's not in local airports, but in some of the really big airports around the world, you'll find that they do exactly that too. For areas where they expect people to move along, they light them with cool colour temperatures. But when you get to the gate lounge, they light it with warmer colour temperatures. So you sit down in the gate lounge and you go, oh, I'm here now. I can't even really be bothered going to the toilet because I'm just sitting here because I'm relaxing, because I'm in this relaxed state. So colour temperature is important. Another thing that's important is the uniformity of light. And again, this is covered by standards, and we're going to talk about them in a minute too. But again, uniformity basically means consistency of light across a place. If that uniformity is interrupted or not even, it also upsets us a little bit and makes us move to different places. So if you want someone to stay still, give them uniform light. If you want someone to move around, give them non-uniform light. And again, airports use that, and you've probably seen it and not realised. When you're in an airport, you go down all these big corridors to the gate lounges, and again, you've seen lots of widely separated down lights, or even lights. You see this dark light, or they put big pillows in the windows that give you daylight coming in across the walkway. And you don't want to stay in these places. You want to get through them and get out of the place. So light interacts with us, in a psychological way in lots of things that we do. I'm going to talk to you also about the difference between engineers and lighting designers. Engineers are great people at doing maths and things like that, but they're not really lighting designers. When we design a building, we quite often use an engineer to do the electrical calculations and all those things, and that's fantastic and they need to be done. We also need to make sure that the building that we're lighting is suitable for the task at hand. The other thing we have to consider is the way that lighting standards have changed, the way that lighting standards haven't changed. The lighting standards that we use in New Zealand now are basically from the 1980s, but now, and they were based on people coming to work at 9 o'clock in the morning, staying till 5 o'clock at night doing their work. Now we've got all this post-COVID working from home, flexible time, all those sort of things. Lots of things have changed about our workplace. So I don't want to turn you all into lighting designers, but I think just understanding a few of these basic concepts will be useful to make sure that if you do change the lighting in your environment, that you are considering some of the things that are important. Human-centric lighting, so this is the natural cycle of circadian rhythm, the natural thing that we do. And one of the things that's come about with LED is this ability to alter this, if you like, mechanically or remotely. And we can show you later with some fittings over here. You'll see some studies out there which say, well, we've worked out that if we give people cool light, they get more excited and they work harder. Likewise, if you give them warm light, they calm down. And there's been studies to show that if we do this in the office place, just after lunch, when people are perhaps a little bit quiet, if you give them a boost of blue light, they work a bit harder, and that's wonderful. You're really working those workers. But you also have to be aware that this is something that you're doing, you're again playing with people's natural rhythms, and it may or may not have an overall benefit. Playing with people, I'll say I won't go into too much detail, but again, playing with people's rhythms like that can be positive. And if you're designing a space station or you've got a 24-hour call centre, you may want to reproduce this cycle through the night time to know your workers are happy. But remember that this cycle is continuous, and when we interrupt it quickly, it is actually what causes jet lag. So when you go on a plane and you fly halfway around the world and you go, oh, that plane was terrible, it made me feel all crazy. The plane didn't do anything to you other than actually shift your daylight cycle. So your body was expecting it to be the evening, you've got somewhere it's the morning, and the body goes, I don't know what's going on now, I'm just going to have to go to sleep and reset myself. So if we start playing around with cycles too much, we can upset people. Any questions on that? Any comment? No? Everyone's happy? Yep.
Just talking about human-centric and consistency uniform lighting, what about people with epilepsy or visual impairments? Can lighting be adjusted in certain areas of the room because they're upon the same cycle?
Absolutely. I mean, people, epilepsy is one that's raised quite a lot, but I mean, it's shown that stroboscopic light, high frequency change of light and will affect epileptic people. And again, lights that flicker, and that may be a fault condition or whatever, or poor quality light has an effect on that. People with visual impairment tend to, and it's not always true, but people with visually, who have, careful what I say, damaged eyes or eyes that don't normally function as well as possible, tend to react better to higher colour temperature lights than warmer lights. So and also more light is useful. As we age, and variety of ages in this room, you realise that as you age, your eyes do age as well, and you need more light to see what's going on. And most of the of people suffering from vision impairment is an accelerated aging cycle, if you like. So when you're a young teenager, you can read a bit of paper under 200 or 300 lux. By the time you hit 50 or 60, you might need 4 or 5 times as much light to read that same size font. And visually impaired people come into that as well. So yeah, if you've got a particular requirement, I mean, you should talk to the lighting people. But basically, more light is good for all those people. That can be adjusted in certain areas. I mean, one of the cool things that we showed about LED lighting used to be quite analog. It was quite, you turn them on, turn them off. Dimming of older technology like fluorescent was a bit complicated. You could do it, but it was expensive. Didn't always work very well, didn't work with some tubes. With LED, basically, the floodgates have opened. You can turn everything on and off. You can vary colour temperatures. You can do all those things automatically. But again, reason talking to you, you're just a bit careful about what you're doing. Brian?
Yes, just adding something to that question. In terms of epilepsy and similar sort of conditions, stroboscopic effects, as Chris has mentioned, and flicker are sort of the trigger points for that. And there are currently no standards applicable in Australia and New Zealand as LCNZ standards that have some sort of control or evaluation of those items. So that's certainly a big gap. And with the rise of LED, certainly flicker is an issue. Sometimes the quality of the product, the electronics are dumbed down, if I could put it that way, and flicker and products can be susceptible to flicker, and many of us have seen these sort of in homes sometimes. So what's in the pipeline now with both IEC international standards and the adaptions for Australia and New Zealand standards bring in what's been called SVM, stroboscopic visibility measure, which is a rating, a scientific rating of stroboscopic effects. In other words, if you wave your hand like that, does it go do-do-do-do, which can be disturbing, and also flicker, called short-term flicker measure. So not quite there yet. It's in the pipeline, and that's a gap that certainly does need to be filled.
With this natural rhythm that we see, the natural changing of daylight, there are companies that are thinking, lighting companies and also lighting people and medical experts thinking that it would be nice to reproduce this inside a building. And I personally agree with that. I think it's a wonderful idea. Probably would make us more comfortable that what's happening inside a building is the same as what's happening outside. Seems like a marvellous plan. But the other thing is, and I think it would work and provide everyone to be more comfortable in their environment. But the other thing we have to consider is, although we like to think that we control our customers or our workers completely, we can't also control what they do outside of their environment. So giving them the perfect work environment will not upset their circadian rhythm. But if they go home and lay in bed for an hour and watch their iPad just before they're trying to go to sleep, the blue light from their iPad or whatever, again, will upset their circadian rhythm, make them difficult to sleep and upset them. So it's a very complex thing. It'd be nice if we could control the whole world, but we can't. So we're going to look a little bit about lighting design, nothing too technical, and I've got a very simple slide here. But one of the first things about lighting design is that more light is better. This seems to be this is something that is beyond question. In New Zealand, when we talk about lighting an office or lighting a commercial space, there is a minimum lighting standard that is supposed to be achieved. It's a very old standard, as I said earlier. And it recommends that the minimum lighting in a New Zealand office is 320 lux. I'm not sure why New Zealand it's a joint New Zealand-Australian standard. We've stayed at this very low level. In Europe, they say the minimum standard should be 500 lux because they think that people work better at that lighting level. And in Europe also, we're seeing a lot more offices, new buildings now being lit to even 700 or 800 lux as standard. That's twice the lighting level of what we're seeing in New Zealand. So these people are expecting their workers to perform better because they're giving them more light. Obviously, we can't go mad. More light costs more energy, and we're talking about saving energy, saving carbon. But also, we must be sure that we're providing, we must view it in the overall context of the environment that we're providing, that it must be suitable for the task that we're asking people to do. Offices are fairly easy. Most people sit there and do their job. But in lots of other places, and I've got a little picture of a residential here, but this also applies to places like hospitals or any sort of place where there's multitasking type things going on. And more we're seeing multitasking type environments occurring. And here, and this is just a very simple diagram, but what we're showing is having more than one light source which can be switched or changed or varied means you can change the lighting in an area. And what this means is, I mean, this is very simple. This is an old-fashioned, if you like, bad lighting. One light source behind the person gives the shadow. Nicer light source. He's got different things here. He's got a desk lamp. You can turn these on, turn this on, turn them off. Having multiple choices both gives us ability to change the lighting environment so we can have a different situation and suitable for task, but also by turning some of the lights off, we're again saving energy. So where previously we had a fine detail task going on, we had to light the whole place to lots and lots of light. We don't need to do that anymore. We need to put the light where it's important, where it's useful, and in areas that aren't so important, we don't need to use the light, use the energy. I mean, slight sort of digression, a little story. I remember when I started in the lighting industry, it's a long time ago now, but we worked, part of my job was working in South Auckland, a lot of abattoirs there, freezing works type places, and meat processing rooms. And there the standard was you had to have 500 lux everywhere in the room. And if there wasn't 500 lux everywhere in the room, they would call a strike and go home for the rest of the day until the lighting was fixed. It was a crazy situation, but that was the standard. So basically these rooms, all these meat processing areas, we had to blast them with so much light so that when the union inspector came in with his light meter and stood in the corner like this, he still had 500 lux on his meter. And that was how light was measured. It was a strange thing. It was nothing to do with how these guys are using great big knives dealing with these big beasts' meat. Nothing to do with the lighting on there. It was whether we had the lighting in the corner. That's what they were measuring. It was crazy. I mean, the world's moved on from that now. We have to think about how we're lighting the environment, how we're lighting our place, and getting the most about making our people comfortable so they can work at their best. So I'm going to talk more about individual applications afterwards, and Brian's now going to talk a bit more about the progression of lighting from a product point of view, I guess. So, Brian.